Distance between 2 points. I've got 3 line segments drawn on this grid, so you will likely want to draw those on your grid as well to follow along. If we're looking at a horizontal line distance, line segment, we can count this distance. We can clearly just count 1, 2, 3, 4 units. So that's this distance. For CD, a vertical one, same idea. We can just count 1, 2, 3, 4, 5, 6 units. But what happens when we have a diagonal line? So with E to F, we can't just count the units. So we need to come up with a new strategy. So what we would do is we would draw a right triangle, and we can figure out this vertical distance and by counting as 4, this vertical distance as 3, and therefore now we could do Pythagoras theory. So we would go c squared equals a squared plus b squared. So if we plug in those numbers, we should be pretty familiar with this. So we're going to get 9 plus 16. And when we square root that, we get a distance of 5. So this distance is 5. So that's the strategy we're going to use when we're finding distance of an angled line. So distance is actually going to be equal to this a squared plus b squared. And then remember, in the end, that's what c squared equals. So we would actually square root this. So that's where our distance formula is going to come about. So the distance formula would be d is equal to the square root of, now instead of writing a, we're going to be given ordered pairs. So to find the distance of a, for example, here we would say 5 minus 2 to give a distance of 3. So we would be subtracting coordinates. So it would be x2 minus x1 squared plus, this is the same idea, 7 minus 3 is a distance of 4, y2 minus y1 squared. Now this formula, you may see it in a couple different ways because you could actually put the y values first, then the x. We call this the change in x or the change in y. You could also write x1 minus x2, and that would be fine as well because you're, as long as it's a difference between that, the formula will work.